All right, I'm gonna get started. Good evening, everyone, and welcome to Crossroads of Ideas, Toxins at the Tap. I'm Hilary Dugan. I'm gonna be your moderator for this evening. I'm an associate professor at UW Center for Limnology, where I research lakes and teach about lakes and water quality. So Crossroads of Ideas is a collaboration between the Wisconsin Institute for Discovery, the Morgridge Institute for Research, and UW-Madison Strategic Communication. It's an opportunity to foster dialogue between the community and UW-Madison researchers. So this series addresses issues that matter to all of us and are also the subject of research at UW-Madison. So since 2014, Crossroads has been a staple of public programming offered at the Discovery Building on UW-Madison's campus. So before I say more about tonight's events and introducing our researchers, we're going to take a moment to acknowledge the land that we occupy here at the Discovery Building. So the Wisconsin Institute for Discovery at UW-Madison acknowledges that it occupies the ancestral lands of the Ho-Chunk Nation, known as Tejope, which means four lakes. The Ho-Chunk have stewarded this land and its waterways, Mendota, Monona, Wabiza, and Kaganza, since time immemorial, maintaining deep cultural, economic, and spiritual ties. We honor their sovereignty and shared strength of standing together with all First Nations of Wisconsin. Tonight, we're here to explore the intricate world of PFAS, or forever chemicals, and the complex challenges these contaminants pose to our environments and to our public health. So we have two outstanding researchers with us here tonight to help explore and unpack this topic, Dr. Christy Remucal and Dr. Manny Teodoro. They're each going to take a few minutes to provide background on their research, and then we're going to finish with a shared conversation. And of course, we're going to save lots of time at the end for audience Q&A. So a brief introduction to both of our presenters today. Dr. Christy Remucal is a professor in the Department of Civil and Environmental Engineering at UW-Madison, with additional affiliations in environmental chemistry and toxicology, freshwater and marine sciences, and the Molecular and Environmental Toxicology Center. Dr. Remucal leads the Aquatic Chemistry Research Group, focusing on the fate of polar organic chemicals, such as pesticides and PFAS, in natural and engineered aquatic systems. Her research aims to develop models and real-world applications to improve water quality. Recently, she was appointed director of the Aquatic Sciences Center, overseeing both the Wisconsin Sea Grant College Program and the University of Wisconsin Water Resource Institute. Next up, we have Dr. Manny Teodoro. He's a professor of public affairs and works at the intersection of politics, public policy, and public management. His research focuses on US environmental policy and implementation, including empirical analysis of environmental justice. His latest book, The Profits of Distrust, argues that the basic services are the bedrock of government legitimacy and links the meteoric rise of the bottled water industry to declining trust in American democracy. In addition, Manny Teodoro pursues a line of applied research on utility management, policy, and finance. He has developed novel methods for analyzing utility rate equity and affordability, and he works directly with governments and water sectors across the US to address policy problems. So with that introduction, I'm going to welcome to the stage Dr. Christy Remucal.
All right, thanks everybody. Can you hear me okay with this? Awesome. See where this goes. Yeah, so I'm Christy Remucal. I'm a professor here, and I'm really happy to see you all today to talk about PFAS. So you're all here today probably because you've seen headlines like this in the news. We hear about these chemicals in our water. We hear about them in fish, in deer. It's important for policy and all sorts of different things. And we hear about PFAS increasingly more and more in the news. And so what I want to do in my introduction is tell you, why do we care so much about these chemicals? Why are they such a big deal? And then share a little bit about some of the research that I'm doing in my own group. So PFAS are a group of over 9,000 different chemicals. This stands for per and polyfluoroalkyl substances. And we actually don't know how many of these chemicals there are. There are thousands of them. These chemicals are used to make things nonstick, waterproof, stain resistant, grease resistant. So they're used in a lot of consumer products. You know, your Teflon pan, your grease-resistant food packaging, upholstery, carpeting, your rain jacket, all sorts of different things that we come in contact with every day. They're also used in firefighting foam, which is really important for water contamination, as we'll get to. And as you can see, we've used them for many, many decades. So these chemicals have been used for a long time. What's the problem? Why are we here talking about them today? There are, I think, 4 things that make PFAS of concern. First, these chemicals have been linked to a variety of adverse health outcomes. Of course, we don't know the toxicity of 9,000 chemicals, but ones that we do know have been linked to things like increased cholesterol, reduced fetal growth, and even cancer in some cases. And one thing that's really important is that these health effects can happen at the concentrations we find in our environment, and so that's a concern, of course. Second, some PFAS can bioaccumulate, so that means they can build up within the food chain, so they can accumulate in fish, for example, and even here in Madison, we have fish advisories for PFAS in some of our water bodies. Third, PFAS dissolve in water, and that means they go wherever water goes. And so that means they're highly mobile in the environment. And we do find these chemicals all over the place. I'll show you some maps in a second. And then finally, we call these forever chemicals. Some PFAS, chemicals like PFOS and PFOA, do not have any known natural degradation processes, so they last potentially forever. And so it's really this combination of things that's concerning: toxicity at relevant levels, the mobility, and the persistence. All these factors together are what makes these chemicals of concern for us. I study environment. I study how these chemicals move around in our environment, where they end up. So how does this happen? We can think about PFAS, for example, leaving our wastewater, like what we flush down the toilet or put down our tap, as well as industry leaving their wastewater. That might end up at a wastewater treatment plant. Landfill leachates, you decide after this, I want to throw out my Teflon pan, and it goes to the landfill. The leachate, the water that flows through your landfill, will also end up at a treatment plant. Wastewater treatment plants are not a source of PFAS. They don't use these chemicals, but they're also not designed or able to remove them either. So that means all that organofluorine that goes in is going to come out the other end. And so that might end up in the water. So here in Madison, our wastewater is discharged to like a river. It might end up in the sludge that goes back to the landfill, and you can see that just kind of keeps cycling things around and around. Or it could end up in biosolids, which of course here in Wisconsin are often land applied for fertilizer. And if those biosolids have PFAS, that's another way of distributing these chemicals around the environment. So you can see that we kind of get things together and then spread them out further in the environment. And then, of course, if we're thinking about environmental contamination or water, we also have to talk about the use of PFAS-containing firefighting foams. So many acronyms. AFFF, aqueous film-forming foams, is what we call these. These types of foams that contain PFAS have been used historically by the military or at airports or even some municipal fire departments. And if these foams are used either for putting out a fire or for training and not contained, this is a really efficient way of getting a lot of PFAS into the environment. And we're dealing with a lot of legacy contamination from those types of uses. So I showed you some headlines at the beginning, and now I want to show you some examples of, this of course is Wisconsin, and where PFAS is occurring in our state and where testing is happening. And so this map comes from the Department of Natural Resources. They have a PFAS data viewer, and it's a really great resource. You can go to it and look up all this data. It's all plotted there for you. And there's a lot going on in this. I wanted to show you all the different things. So first, just drawing your attention to all the green circles, the ones that look like this. Those green circles, those are places, municipal drinking water sources where they tested for PFAS but did not detect them. So I wanted to show that we're doing a lot of testing in the state to find out where we have contamination. I think that's really good and really important. We have to know where these chemicals are to do anything about it. So those we don't need to worry about, but maybe what we do need to be more concerned about are the orange squares. Those are active PFAS contamination sites. And then the orange and yellow circles, those are drinking water utilities that have PFAS concentrations that are of concern. And you can see there's a lot of communities here in Wisconsin that show up on this map. And so this just gives you a sense, this is just for Wisconsin, but you find this in other places as well, that we really are finding these chemicals in many different places. All right, so what do? I study PFAS in the environment. I'm really looking at getting a handle on the scope of contamination. And so I want to just highlight briefly 3 areas where we work. The first is looking at PFAS sources. So we're here today to talk about drinking water. So how do these chemicals get into our water? So one area where I've done a lot of work is looking at PFAS getting into our Great Lakes. The Great Lakes are a drinking water source for 40 million people, an incredibly important water resource supporting fisheries and so many other things. And if we know how these chemicals are getting into these really important water bodies, we could think about maybe preventing future contamination. So I'm not going to talk you through too much data. I'm just going to show some more news headlines because that's a little bit easier. It gets you at the scope of it. But some of the things we've done are looking at how rivers are important for getting PFAS into the Great Lakes. Not a surprise, rivers do bring these chemicals into the lakes. And it turns out the bigger the river, the more water it has, the more PFAS it puts into the lake. So that's kind of some of the findings of our work there, which is maybe intuitive, but good to know. We've also looked at groundwater. If you have contaminated groundwater and that flows into like Lake Michigan, that of course brings PFAS with it. And so that's these are some of the ways these chemicals are getting into the Great Lakes. For current work that we have going on, we're still working on the Great Lakes, but some new upcoming work is focusing on groundwater. So most people in Wisconsin, 70% of people in Wisconsin drink groundwater. So that's the water that's underneath the ground that we pump up. That's true here in Madison. And importantly, about a quarter of our population drinks private drinking water wells. So drinks from private wells. I showed you that map before. Those were municipal water sources. They weren't private wells. But groundwater is a really, really important water resource for us. And so we're doing things like looking at how important are biosolids? What about landfill leachates? What are some of these other sources for potentially impacting our groundwater? So the second area is like looking at how these chemicals move in our environment. So I told you they dissolve in water, they move wherever water goes, but of course they're found in other media as well. So we look at PFAS in sediment, like at the bottom of the lake or at a river. We look at PFAS in ice. So what happens at the surface of, in the winter when our lakes freeze. And then I wanted to highlight this recent study that came out maybe about last year, looking at PFAS in foam. So if you've been to like a lake on like a windy day, you've seen that foam that sort of forms naturally on the side of the lake, and you can also see it like downstream of a dam, like if there's a lot of air bubbles getting like introduced to the water. Most of what's in the foam is not PFAS, but what we found is that PFAS really like to accumulate in that foam. So we found that concentrations of PFAS were 50 to 7,000 times higher in foam than in the water below. And so this was really interesting finding, a little bit, raised some eyebrows, but don't touch the foam is the story from, that's sort of the message there. All right, last thing I told you, we studied there are over 9,000 different PFAS. We normally measure like 40 of them in our lab. That's true for most people because for a lot of complicated chemistry, I'll spare you on. But what we're doing now, other groups are applying new advanced technologies for looking at more PFAS that are out there to get a bigger handle of all these different chemicals. And this is maybe a lofty dream, but where we're wanting to go with this, it's sort of like PFAS forensics. If we can look at the chemistry, like say in a lake or in a river, and based on that chemistry, we could say, hey, this had to come from this source. We could trace things back. So that's kind of where we're going with some of this work. So like I said, we're really problem focused, but before I hand it over to Manny, I do want to say like, okay, so what do we do about this? These chemicals are everywhere, they're toxic and they're in our water, what do we do? So first, it's important to know there are ways of removing these chemicals from water. So things like activated carbon, ion exchange, reverse osmosis, those can, if you have PFAS in your water, they can remove them. One thing that's important to know though is that these technologies that we're using right now do not destroy the chemical. So you still end up with activated carbon that now has PFAS in it, and you have to do something with that, send it to the landfill or regenerate it somehow. So this can do things in the short term, and a lot of the communities I showed you where they're detecting PFAS, this is what they're doing for cleaning up their water. What I think is really promising is that there's a ton of research going on in remediation, destructive technologies. And I think we're not quite there yet in terms of commercially available technologies, but there is so much energy and movement in here that we're getting there, and that gives me a lot of hope. And then the last thing I want to just leave you with before I hand it over to Manny is I think long-term decreasing our use of these chemicals is important. And so there are choices we all can make to for our own, if you're buying a raincoat or a pan or something like that, to think about decreasing our use of these chemicals. And I think if we're able to do that, long-term prevention is key, because these chemicals are challenging to remediate, and preventing contamination is the most efficient part. So I'm going to hand it over to Manny, who's going to touch on regulation and policy, which of course is an incredibly important part of this puzzle.
Thank you, Christy. I have to start, before I start on my remarks, I want to start by appreciating everyone who came out tonight. You are people who chose to step away from what I think is probably the prettiest spring evening that we've had so far this year. I know looking at the number of RSVPs, we were expecting more people here, but to be honest with you, looking at it outside, I can't blame any of these people for not showing up. So, however, that means you few, we happy few, will carry on, and you are our kinds of people. You're the kinds of people who would show up to a windowless room on the prettiest evening of the spring and listen to a couple professors talk about water contaminants. So, thank you for showing up. I am not a toxicologist, and I'm not an engineer. So I cannot speak to the health risks or the technologies to mitigate the risks associated with PFAS. That's one of the reasons I'm generally grateful for Christy's work, but I'm especially grateful that she's on the stage with me tonight, so you can ask the hard questions of her instead of me. What I study is public policy. I work at the La Follette School, where we study public policy, public management at the intersection of economics, sociology, public administration, and politics. Economics is, of course, the dismal science. Public administration is the craft of the practical, and politics is the art of the possible. I'll be speaking to each of those around PFAS tonight. So when we talk about PFAS, let me see if I got my clicker working here. There we go. I'm going to talk about PFAS regulation with respect to drinking water, and I want to make sure I focus on that, because, as you know, it's the theme of our talk tonight. Christy mentioned briefly, drinking water is not the only or maybe the most important vector of PFAS into human health, but it is an important one, and perhaps the most regulated one we've got is drinking water. So that's what I'm going to talk about, and I'm going to talk principally about PFAS regulations for community water systems. I will speak briefly about private wells in just a moment, but I'm going to talk mostly about community water systems. Give you a little bit of background. The principal way that we regulate community water systems is something called the Safe Drinking Water Act. It was passed in 1974. It's about 50 years old now, and it's built on this sort of typical federalist arrangement that we have for most of our environmental laws in the United States. So Congress passes this law, the EPA at the national level sets regulations, and then state regulatory officials can strengthen those regulations if they prefer, but they also they have what's called primacy, which means they are principally responsible for the implementation of these laws. There are state bureaucrats, state agencies that handle the implementation and the regulation of the community water systems, but ultimately it's the community water systems that are responsible for sending water through pipes, out of the ground or out of the lake and into the pipe and into the home. So it's really all three levels of government involved in delivering water. And one thing that's different about drinking water from most other things that the EPA regulates is the ultimate water utilities that ultimately have to comply with these rules are almost all governments, especially in Wisconsin. So about 85% of Americans get their drinking water from a local government. And in Wisconsin, we have 572 regulated community water systems. All but one of them is owned by a local government. So they're all local governments. We're talking about not about industry, regulating industry. We're talking about governments regulating local governments. So it's governments regulating governments. To give you a little bit of a short history of the PFAS rule and how we started regulating it, EPA started tracking PFAS in drinking water about 25 years ago. Long before it was regulated, started tracking the data. Wisconsin's been ahead of this curve. Wisconsin and a handful of other states, Michigan, maybe it's a Great Lakes ethic or something. Michigan, Minnesota are among the leaders in tracking and testing PFAS in drinking water. Wisconsin and a number of other states over the past decade set their own PFAS standards well before EPA did. So before it was regulated at the national level, we had a handful of states, including Wisconsin. Wisconsin, it's a long and tortured history around the PFAS rule in this state. Where we landed was 70 parts per trillion. That was the PFAS rule in this state. EPA last year finalized its new rule nationally at 4 parts per trillion. So it's a much, much more aggressive level of regulation. And I want to give you a little bit of context, especially for those like me who don't think about parts per trillions and nanograms per liter and whatnot. By contrast, Japan's standard is 50 parts per trillion. Canada is 30 parts per trillion. Australia is at 70 parts per trillion, just like the Wisconsin rule, although they are currently reviewing and set to publish any day now a rule that was proposed at 4 parts per trillion. So Australia may be following the United States. Most of Europe is either at 20 parts per trillion or 100 parts per trillion, depends on the country in the EU. Only Denmark has a lower standard than the United States at 2 parts per trillion. So I say all of that just to give you the context of how aggressive EPA's rule is. It's really surprised people in the water industry when they came out with 4 parts per trillion because it is very, very aggressive, certainly relative to what's in the rest of the world. Implementation of that rule is underway right now, and Wisconsin does have a head start because we regulated it early in this state, not at 4 parts per trillion, but because we were monitoring earlier, much more extensively, and implementing our own state level rule. We're sort of ahead of the curve. All right, so that's your background. Now to research. I'm going to start with the dismal. The cost of compliance. EPA estimates that the annual cost of compliance with the PFAS rule will be about $1.5 billion. The American Water Works Association estimates that at $3.5 billion. Now, I think it's fair to say, looking at the methodology, EPA has got a little bit of rosy tint glasses, and AWWA is maybe a little too pessimistic. But I think you can think of $1.5 billion to $3.5 billion as a reasonable range for what it's probably going to cost us to address PFAS in drinking water in the United States. The thing is, so now again, just for some context, that's about a 2 to 5% increase in total rate revenue across the United States. So if you look on average, it's about 2 to 5% increase in the cost of water for the monthly bill across the US. But the thing is, those costs are not randomly or uniformly distributed. You remember that map? We're going to look at it again. The map that Christy showed us a little while ago. I'm going to show you the same map again in a moment, but you notice they're not randomly scattered across the state, right? The places where we have, there's some places that have high concentrations of PFAS and other places where there's none at all, or none at detectable levels, none that we would be concerned about. So Wausau is a great example. So Wausau had significant PFAS contamination and had to spend $17 million on a new treatment plant, which is a lot of money for a community that size, for a population around 40,000. So $17 million, that's about $1,000 per household, and rates have had to roughly double over the past 3 years in order to pay for that new facility. Now today, Wausau has excellent tap water, but their rates also increased by 100% over this 3-year period. So that's painful for a lot of customers. By contrast, Menominee Falls, which has roughly the same population as Wausau, has no significant PFAS, and so its rates haven't gone up. So to give you a sense, in Menominee Falls, a month of water service for a family of 4 costs about $30, and in Wausau, it's about $54. So that's a real non-trivial increase in the cost to the people in Wausau. So that's the direct cost. The much more serious, and in some ways much more dismal thing is the opportunity cost. PFAS is a health risk for all the reasons that Christy outlined, but the thing to keep in mind is that $1 spent on PFAS remediation is $1 not spent on something else. And that's the thing that we worry about all the time up at the Follett School. If we focus on this thing, what are we not doing? What are we comparing it to? So Madison is a really nice example here. Madison, many of you probably live here or nearby. Last year, Madison spent $6 million on the remediation of well 15. Madison has, I think, 23, 24 wells citywide, and one of them had a PFAS detected at above the EPA standard, below the Wisconsin standard, but above the EPA standard. And Madison spent $6 million remediating that well. However, Madison averages 200 main breaks every single year, 200 water main breaks. every single year. For the same price that we just spent on remediation of a single well, we could have replaced roughly 4 miles of water main. So these are not inexpensive opportunity costs here. $1 spent on PFAS is $1 we didn't spend on mains. Main breaks increase all kinds of risks. They risk catastrophic failure in addition to the inconvenience and the risks to our operators who have to go out and repair them on the coldest day of the year. They also introduce the possibility of biological pathogens into our water systems. I'm going to go back to that same map. Christy showed it to you before. And I want to point out that just 9 of the municipal water systems in Wisconsin have PFAS levels above the advisory level in Wisconsin. If we go to the more aggressive EPA number, that increases. So if we take the EPA standard, we actually are at 24. We have 24 systems with PFAS detected above 4 parts per trillion. So that gives you a sense of what we're talking about, but that's 24 out of 572 utilities. Meanwhile, in 2023, we had 163 utilities with coliform detected above the EPA standard. Now, coliform is what we would call an acute contaminant. It's a thing that makes you sick right now. And if it's not increasing your risk of something perhaps in the future, but a thing that makes you sick right now, and if you're immune compromised, might kill you right now. So there are real costs to investing money in PFAS remediation and not water mains or not something less exotic. Now, I want to be clear, I am not saying that PFAS isn't an important issue. Of course it is. It's simply to put it in context. So PFAS is sort of the contaminant du jour in the news media, and it's important, but let's not take our eye off the ball. Coliform kills people. Coliform is a very, very serious contaminant, Legionnaire's disease. These are nitrates, probably a much more serious risk if you are a rural private well owner. Nitrate is probably a much more serious risk. So I just urge us not to take our eye off the ball. If you are in Wausau, PFAS is probably your #1 concern. Most of the state, though, probably not. I want to take just a minute to talk about private wells. Nationally, less than 10% of the population uses private wells. And in Wisconsin, actually my numbers are even higher than what Christy told you. By my numbers, about 1/3 of the population in Wisconsin is on private wells. And that's really, really high compared to the rest of the United States. From a regulatory standpoint, the only thing I want to say is that PFAS in private well water is effectively unregulated. It's the owner's problem. So from a regulatory standpoint, the Safe Drinking Water Act does not touch private wells. It's just not related. However, again, most of the state, if you're not near one of those orange dots on our map, there's a good chance that nitrates are a more serious threat to your water than is PFAS. Okay, so the last thing I want to talk about is implementation of this law. It just went into effect. Final adoption of the PFAS rule was last year. The deadlines the EPA has set is every utility, every water system in the country has to be monitoring for all of the PFAS by 2027, all the regulated PFAS. There are 6 of them. Christy mentioned there are thousands and thousands and thousands. We're regulating 6. Okay. So we have to monitor all 6 of them by 2027. Full compliance with the PFAS rule, that means getting under 4 parts per trillion by 2029. The larger, more well-resourced utilities will probably comply fairly quickly and fairly easily. Your Madisons, your Milwaukees, they're going to be okay complying with these rules. The smaller, poorer communities will probably not. They're probably going to struggle to meet these rules. They're probably going to fail to meet these rules. And then it's going to be up to DNR and the EPA, Department of Natural Resources here in Wisconsin, and the federal EPA to decide what to do about that. They're all going to be involved. The last thing I want to say is talk about where we're going in the future. I don't know exactly how the implementation is going to work out, but the one thing I'm very confident about is that the PFAS rule and regulating PFAS is a full employment program for environmental lawyers. There is going to be just lawsuit after lawsuit after lawsuit, and they've already begun. Customers will sue utilities. Utilities will sue the chemical industry. The chemical industry will sue EPA. The utilities will sue EPA. All of the utilities and the customers are going to sue, and environmental organizations are going to sue state regulators. So there's going to be lawsuits aplenty. If you want to make a lot of money and you're in law school right now, this is a good line to get into. You're going to do really, really well with PFAS. So that liability fight is going to be all over the country, and that brings us to how do we get out of that? The only winners there are going to be the lawyers. How do we get out of this box? I'm going to point to the tobacco settlements. Those of you who might remember the 1990s. We had a settlement between the tobacco industry and the state attorneys general to settle the costs of liability because the cost of tobacco liability were so astronomical and nobody was winning. So I think that the future, if there is a happy future from a regulatory standpoint, it's going to be a similar settlement between state attorneys general and the chemical industry and the other industries that were heavily involved in manufacture and distribution of PFAS. And the one place where we are going to need federal law, we're going to need Congress to step in and provide liability protection for utilities. Because otherwise, poor Wausau is going to be stuck on the hook paying liability for cancers that it didn't cause because it was pumping water out of the ground. So that's the sort of the two pieces we need. That's going to require some politics, some clever politicians, and that's where we get to the art of the possible. So the good news is, and then in the end, private wells. I don't know. I don't know about private wells. I don't know where we go. I wish I had a good answer for that. I don't know how we deal with private wells. It's just going to be outrageously expensive to try to remediate all the private wells in the United States, particularly in places like Wisconsin, where so much of our population's on it. The only good news I can offer you, I always like to end with good news. Good news, PFAS levels in blood are falling precipitously over the last 25 years as industry has been phasing these chemicals out of use. So it is, the good news is we are not using this stuff nearly as much as we used to, and so less of it is getting into the environment, and that's the best I can offer for good news. Right.
Thank you.
Yeah.
All right, well, thank you both very much for your talks. I learned a lot, which is great, but I also have some questions for you. So I'm going to start this discussion by asking our speakers some questions, and then I'm going to turn it over to the audience. So to start off, Christy, with not touching the foam, I'm a limnologist, and so I always get questions about foam on lakes. Everyone wants to know about the foam. And usually we say it's fine. We're like, oh, it's just natural, just organic stuff in the lake, foaming up when it's windy. And Christy's study came out last year, which, as she mentioned, showed that there was lots of PFAS in the foam. So can you tell us more about when people interact with water, so be that swimming, drinking it, eating fish from lakes, do we know much about how we're actually getting PFAS into our body?
Yeah, so what we think, is that all right? I can move on the other side. What we think right now is that ingestion is the major route of exposure. And so that's going to be either through drinking water or eating food that has PFAS, so like fish, for example. Dermal contact, so that's contact with your skin, is less of a concern. So when the foam study came out, I talked to a lot of media, and people are like, well, what do we do? And I think one thing to say first is like most of what's in the foam is not PFAS. It's like less than 0.001%. Like most of its other stuff, it's like from algae and leaves, and like it is naturally present stuff. But I have kids, so I think about the kids. You watch kids playing in the foam, and then they run over and like grab food and like don't wash their hands. Like I'm like that kind of grosses me out a little bit. So, so I think about it from that context. But yeah, ingestion is really the main route of exposure.
Yeah. Okay. And then when we think about these forever chemicals, that name suggests they don't break down. So are there degradation pathways in the environment that are taking place such that if we stopped having inputs into our rivers and our groundwater, it would naturally sort of either flush out or degrade over time?
Yeah, it depends. I think that's my favorite answer. We'll count how many times I say that. So that's one. There are thousands of these different chemicals, and some of them do transform in the environment. The problem is they transform into things like PFOA and PFOS that don't transform. And so yes and no. For things like PFOS and PFOA and all that Manny was talking about, it's mainly those chemicals are the ones that get a lot of the attention from a regulatory perspective. Those, as far as we know, don't have any known natural degradation pathways in the environment.
Okay. And do they stay in the water? So will they move with the water?
They do move with the water, but because they're pretty soluble, they dissolve in the water pretty regularly, but they do also partition to sediment and fish and things like that. And that's spare you all the complicated chemistry of why that happens, but that's a concern because that means we need to think about, if we're thinking about remediation, we need to think about water, we need to think about sediment, we need to kind of think about everything.
Mm-hmm. Yeah, absolutely.
One thing I left my turned on here. That sounds like I'm not. Do I need to hit anything? Or are we good?
There should be a little button.
We're good? All right. So one of the things I wanted to highlight that Christy mentioned briefly in her talk was what happens when we have an activated carbon or ion exchange or something. What do we got? We've got a filter full of PFAS.
Mm-hmm.
So, I mean, great, it's not in the drinking water, but now we've got a thing that's designed to be indestructible, and we've just soaked some kind of a filtration medium in this indestructible thing. One of the things we don't know really how to do from a regulatory standpoint is how to dispose of this stuff. And that's kind of coming down the next path, right? Like that's coming down the path, I should say. Once we get into full implementation of this rule, we're going to have to do something about the destruction of these filtration media. And right now, we just don't know what to do.
Yep.
There's a lot of smart people working on this.
It's the nuclear waste problem.
It's a nuclear waste problem.
You just store it until you figure out where to put it.
Yeah, that's right.
Yeah, interesting. So thinking about the regulatory, and you talked about lawsuits and utilities and polluters, do we, at this point, do we have a good sense of all of the sources that are putting PFAS into our water? Or are there still unknown polluters that we just haven't figured out yet?
I think that's a you guys.
I was hoping you were going to take that one. So
I think the safe answer is we don't know.
Okay.
But I imagine there's a lot of lawyers trying to figure that out. Look, one of the big priorities for the water systems in this country, the Madison Water Utility, Milwaukee Waterworks, they are really worried about liability here, because right now the law that would seem to apply is CERCLA or Superfund, which is a strict joint liability law, which lawyers. I'm not a lawyer, but lawyers tell me that means if you ever touch the PFAS at any point in any part of your business, you're now responsible. Which means that one reading of CERCLA, the Superfund law, says that every utility that has PFAS detected at any level in its water is now responsible for it from a financial standpoint, and the full weight of the law could fall on those utilities, which I'm very sympathetic to the utilities. They're saying, like, wait a second, we didn't put this stuff in the earth. Why are we're just pumping groundwater like we have for 100 years? Why are we stuck on the hook for this financial liability? So a lot of what's happening right now is trying to figure that out. I wish it was more driven by the science. I think Christy's doing God's work here by trying to fingerprint these things. But I think a lot of this stuff's driven by the search for liability.
Sure.
Lawyers trying to figure out who to finger for liability for these chemicals. Yeah,
and in the United States, we have seen water utilities fail and go bankrupt for a variety of reasons, sometimes related to climate disasters or other pollutants. And historically, the federal government stepped in, but when you have this many providers,
Sure.
It just won't be possible.
Yeah. Well, and I'll go back to the opportunity cost. What are these utilities not going to be able to do because they're paying settlements, lawsuits. Settling lawsuits. This is why, again, I think the model we need to try to think about here is that tobacco settlement from 30 years ago, where that's what finally got through that Gordian knot of tobacco liability. We're going to need something that significant, I think.
Sure, but unfortunately, that timeline's still a ways out, and utilities are dealing with the rising costs of these treatments today.
Absolutely.
Yeah. How are we doing for time? So I think at this point we have about 15 minutes or so left. So I think it'd be great to open up the floor to questions. I will ask, there's going to be a couple microphones that are being passed around. So we need to have the question on mic. So yeah.
There's a button on the.
Oh, the light's on now.
This may be a loaded question, but what does the current political situation have to do with regulation, remediation, and some of the efforts that you're talking about?
Yeah, I think you both will have great answers to that question if you're able to.
I think the only, like I said a second ago, the only safe answer to that question is who the hell knows, right? I feel like I wake up every morning and there's like a random number generator that creates news out of Washington. And I think that there's a tremendous amount of uncertainty out there. Look, I will say this. You know, President Trump has made some unorthodox selections to lead his agencies. I'm not good at diplomacy, but I'm doing my best here. However, I would say in EPA, in the Office of Water, the people who are at least in the designated appointed positions are serious people. They are folks who are experienced in the environment. So, you know, let's hope it stays that way. I think these are serious folks that are not going to be completely capricious the way maybe some other agencies would be. What does it mean for the future? I think you know, it doesn't take a political scientist to look at the current Congress and the current administration and guess that we're not going to see $2 billion from Uncle Sam every year to pay for water, for PFAS remediation. This is going to be a local problem. So to the extent there's going to be any help for the Wausau's of the world, it's going to have to come from the state houses. And I think it's been encouraging, at least in this state, it's been a rare spot of bipartisanship. I think both Republicans and Democrats in our state legislature have taken PFAS very seriously. And so I think there's reason to expect that. But I would be surprised if Congress came through with anything significant on this front. Even untangling the PFAS rule, you know, even if it gets thrown out in court, that's going to take a long time. And I do not think the congressional cavalry is coming to save America's water systems.
Mm-hmm.
I have a question. Could you speak a little bit to the state legislation that's being introduced now in the State House in Wisconsin about PFAS? There's like a Republican-supported bill, and then I think Governor Evers has his own version of how to mitigate PFAS. Are you familiar with those bills?
I'm familiar with the governor's proposed budget, which, yeah, I had the headline for that. And the legislation, I don't know the current status of it at the moment. I don't know
Yeah,
if you know
I
more.
couldn't speak to the details of that legislation either.
Okay,
I'm sorry.
thanks.
Thank you. What is the most commonly used biomarker for health monitoring?
Oh, that's a great question that I don't know that I know the answer to. I think one thing that's really challenging, I showed you that sort of infographic that had a whole long list of different adverse health outcomes, is there's a lot of different things that are impacted. It's not just one single, like this cancer or this cholesterol issue. Like it's really complex. So I don't know about specific biomarkers for PFAS exposure. I know there are studies where people measure just like PFAS in blood. Manny talked about that those levels are going down, like direct measurements in like serum, like your blood serum. But I don't know about tying that to specific health outcomes is really complicated, and I don't know that we're quite there yet.
Great discussion. The boxes that you had on your first map seem to follow I-90, I-94, and I-39, along with I-41 up to Green Bay. They may just be population centers. Is that the determining for the concentration? Or is there something about having lots of people together in a concentrated place where the chemicals would concentrate?
I think not necessarily. I think a lot of the contamination, maybe this is speaking more nationally, we see a lot more contamination near AFFF, like the firefighting foam sites. That's certainly true here in Wisconsin. I mean, if we think about population, our concentrations in Madison are pretty low. That data's out there. So I don't know that it's necessarily tied to population. It's more like a lot of use of those chemicals. A lot of times it's firefighting foam, but not always. You talked about industry too.
I think nationally it's industrial sites. Now those often are also population centers, but not always. You know, where you have a rural, isolated industrial site. It could be an airport, for example, could be kind of isolated, but it's industrial sites. One of the advantages, one of the things that's strange about PFAS compared with a lot of other water contaminants, if you look at the correlation between PFAS contamination and, say, socioeconomic status, poverty, education, income, it's different from what you see for other kinds of contaminants. PFAS is actually positively correlated with local income and negatively correlated with poverty. One of the advantages of having never industrialized and therefore being poor is that you don't get post-industrial contamination. So, hooray.
Is there also a chance that we test more in population centers? Like, is our testing in Madison and Milwaukee at a higher rate than rural locations?
I'm thinking of there's been some work looking at like PFAS and like blood measurements and looking at that correlations with socioeconomic status here in Wisconsin, and it maps what Manny just talked about.
Yeah.
So,
Interesting.
yeah.
Cool. Yep, go for it.
Yeah, sorry. Since there are 9,000 plus compounds to choose from, how are the few compounds that are regulated selected? And how specific are the tests that are used to detect these compounds? In other words, did they detect a family of chemicals, or are they very specific to just those 8 regulated compounds?
Yeah, so I'll maybe speak to your second question first. The methods that we measure for measuring these chemicals are very specific to those individual chemicals. So it's like it's PFOS or it's PFOA. And I can take a guess about those chemicals in particular, and then please add on with other thoughts on it. But my couple things. First, we did used to use a lot of PFOS and PFOA specifically. Those are the ones that we just used in a lot of products like Teflon pans or Scotch Guard and things like that. That's what were used. They have a really long history of use. We know a lot more about their toxicity. So a lot of the regulations are driven by toxicity, so we need to have that data. And these are the ones that don't break down as far as we know. So they've been used for a long time. They were used in maybe larger amounts. We know they're toxic and they last forever. So I think it's all those factors together that come into play.
I got nothing.
Okay.
I have a practical question. I buy bottled water. Is that better than, just getting the water out of the tap? Or worse?
You want to take it?
It depends on where your tap is. I mean, if it's in Madison, your tap is probably pretty safe. I mean, unless you have, and Madison has eliminated all of its lead service lines, so you should be safe from service lines. So as long as your domestic plumbing is in good shape, like what's inside your home, your tap water should be pretty safe. Bottled water, one of the things people don't realize, bottled water is hardly regulated at all. Your tap water is extremely rigorously regulated, particularly in a place like Madison that is very professionally run. It's a very modern utility. Bottled water the bottled water manufacturer in this state, it doesn't matter who you're buying it from, it gets tested once a year. Each of the wells in Madison gets tested several times a day. So we're talking orders of magnitude higher confidence in what's happening in the tap water. So my general view is that you're almost anywhere in the United States, you're better off with tap water than with a bottle. We don't even have to start talking about microplastics. This is just like a little microplastic machine right here.
One thing to add to that, so how many of you live in Madison? A lot of folks. So our utility is really good about putting out the data on what's in your water. So you can go to the Madison website and look up, put in your address, figure out which wells serve your home. So there are 20-some wells. You can be like, I'm served by wells 2, 3, and 6. And then you can go and look up the concentrations of PFAS in your water. And so that's you can do that. It's below all the regulations, and that's just, it's good to know. I don't know, but our utility's been really good about putting that data out there, so you can go and find that out.
Just for fun, I download every year the data. This is the kind of guy I am. I download all the data from the Department of Agriculture here, who tests our bottled water manufacturers. Again, one test a year. And they put it out there, and it turns out that they violate the Safe Drinking Water Act standards at exactly the same rate as our utilities do. So you're paying something like 150 to 200 times the unit cost for a bottle of water as you'd pay at the tap for a less rigorously regulated product. Now, you know, the one caveat to all of this is Wisconsin, as Christy mentioned, we're mostly on groundwater. Our groundwater's kind of hard. It's going to have that mineral taste to it. So if the mineral taste bothers you and you really want the bottled product instead, then that's a reason to drink the bottled product. But
Well, thank you.
It's often public water from another city.
yeah, that is true.
Thank you. My name is Lance Green. I'm the co-chair of the Friends of Starkweather Creek. And those of you who live around Madison know that we have a very serious problem of PFAS coming from the airport into the creek, into the lakes. Right below the, you can look on our website and find the results of testing we did all over Dane County last fall. We tested the PFAS levels of a lot of the waters here. Right below the airport, it was hundreds and hundreds of times the standard. And for those of you considering eating the fish in our lakes, well, Mendota is fine, but the fish in Monona and on down are really high. And we're not talking about 4 or 50 or 70 parts per trillion, 150 to 200,000 parts per trillion. And so we do have an environmental injustice issue going on right here in Madison. The people who are eating those fish are generally people of lesser wealth, and they are along the shores of Lake Monona getting those fish all the time. So this is a concern that our organization is concerned about, and we would certainly like to see a lot more done to clean it up and to keep people from eating those fish. I'm just wondering if you guys can talk any about the health effects of eating that levels, those really high levels, and you know, is that much more of a problem than drinking the water at 4 parts per trillion when you're eating fish at 200,000 parts per trillion?
Yeah, I mean, I think, again, it all depends on how you all factor it in, but certainly there are fish advisories on those water bodies for a reason, and that's, I mean, I think the Department of Health has done those calculations to figure out, like, what the acceptable risk is. But I think from a, like, I don't know, it's like the amount of chemical you get in your body, whether you're getting it through your water or your food, like, the chemical's still the chemical. So it all, you have to kind of, I don't know really where I'm going with that, but, like, they both,
Yeah.
you have to, like, sort of do the math and, like, how much fish you're eating versus how much water, and factor in all those things to kind of answer that.
Yeah, and I'll add too, the science on PFAS in the food web is certainly, you know, there's a lot more work to do than some of the other contaminants that we historically know a lot more about. We have mercury advisories, for instance, on fish in Monona for similar industrial legacy reasons. And we just know a lot more about how things like mercury bioaccumulate, that, you know, it's higher in bigger fish, that it's only found in some parts of the fish, and so that, you know, it can change in terms of how you're actually eating the fish, like if you're eating the whole fish versus just filleting it and taking, you know, parts of it. And there's just, with PFAS, it's such a new problem that there's still a lot of work to be done trying to learn how it exists in aquatic food chains. In terms of the testing that's been done on the lakes in Madison, it seems like it's different than other contaminants in terms of it's not necessarily higher in bigger fish. It can be just as high in small fish, and so that kind of goes against some of the current advisories, which really deal with fish size, which is like you can eat a lot of, like, go to town on the bluegill, but, you know, stay away from the big walleye. But with PFAS, it's different, and you know, there's still a lot of work being done to figure out how it's present in the food web and then how it gets to humans. So a lot of ongoing work in that area.
We live in Madison, so I'm encouraged to hear that the water supply is relatively safe, and that's good news. We have a second home, though, it's on a well, and so as I understand it, they don't really test for PFAS when you're getting your well tested. So how are those of us who have those to monitor for that? Is there a proxy that if the town that you're nearby has good water quality, you may assume that as well, or is there some way that you might be able to determine that?
I think there's a lot of variability, so it's hard to make an assumption just because the municipal water down the road is at this level. Like, there's just a lot of variability underneath
Just
the
within
ground.
Madison alone. Like,
Yeah. So, I mean, I think, as a private well owner, like, you can get your water tested. There are inequities here. It's not cheap. It's like $400 a sample to do that, but you can do that. But it's
For PFAS.
for PFAS. Yeah.
That's right.
Yeah.
That's right. Those costs are coming down, though. And as the PFAS rule gets implemented more and more, that there are going to be more and more testing facilities out there, the average costs will come down. But yeah, I mean, if you have a private well, you're on your own, right? There's effectively no regulation to protect those.
I would say too, if you have a good sense of sort of how deep your well is and how connected it is to the watershed where your property is, if there are reasons to suspect that there's high PFAS contamination, which might be, looking at some of these data viewers and seeing if there's anything been tested nearby, or of industry that was in the area, then might recommend testing versus, if there's no reason to suspect any kind of contamination, there are, as the map showed, most places in Wisconsin are well below any of these levels of concern.
I think one other thing to say with groundwater is groundwater moves really slowly, so it's not something you would need to test like every year. It's probably you do a test once, and then like you kind of know where you're at. Like, it's not changing a lot. So I think for a private well, that might be a good route to go. But sometimes there are some surprises, like places you wouldn't expect. So I don't know. You can't always just assume, I would think.
And there's some, these data viewers are, continually getting better and aggregating more data. And there are some private groundwater viewers that are run. There's one run by the University of Stevens Point. I don't know if it includes PFAS yet, but it includes a lot of contaminants that were tested on private wells, and no doubt at some point, I'm sure PFAS will be added to that. All right. Well, we're at the hour, so I'm going to ask you to thank Dr. Remucal and Dr. Teodoro for such an inspiring conversation tonight.
And thanks for coming out again.
Yeah, thanks, everybody.
And many thanks for you being here with us. This was the final Crossroads of Idea program for this academic year, but stay tuned to the WID Discovery Hub website to find dates and topics for next academic year. And thank you again for joining us.